Recording. Okay, so I have just discussed with my class how they should come into the room. As soon as you come into the room, make sure that you get a binder. The topic for today is Chapter 7, Number 3. That means that on the grade grid under Need to Start, you need to put Number 3 sometime today because Number 3 is new for today. Then the essential question is also written over there on the objective board. The essential question for today is how do I add like terms if there are exponents? Now, an exponent is a little number on top. So you can remember that we were adding like terms, just a second. We were adding like terms, and they were like if they had a letter. But what if there's a letter, and that little letter has a little number on top as well? So that's the only difference for today. And new for today is not a bunch, but some vocabulary, and it is all super easy. So this is probably the easiest day of the whole semester, vocabulary. So there's some new vocabulary for this unit. Alright, and so I'm going to make some boxes going across the top here and then going down. So I'm going to put the word on the left, and then I'm going to put the definition in the middle, and then I'm going to put an example over on the right. So here is a word, and here is a definition, and here is an example. Okay, the words are... yes, I would like you to make this graphic organizer for your vocabulary for today. Okay, our words for today are monomial, binomial, trinomial, term, coefficients, and exponents. Yes, this is going to take up the whole page. Monomial, binomial, trinomial, term, coefficients, and exponents. And I think black would be a much better color for these. Is black good? Let's do blue. Okay, so a monomial is an expression with one term. And the reason why it's called monomial and it means one, for example, there's a disease called mono that you get from kissing people, and the reason why they call that mono is because you can only catch it once. So if you wanted to, like out to the right here is a drawing, then I'm going to draw like a pair of lips because I'm going to remember that a monomial can only be caught once. Okay, and an example of a monomial is 3x to the third. So that only has one term. Even though there's a 3 and an x and a little number 3 on top, there's only one term there, and so there's only, it's a monomial. And a binomial is obviously an expression with two terms. No, there is not a bi. Well, there's all kinds of things. I'm going to make a drawing over here for why the prefix is bi here. But let's do an example first. An example of a binomial might be 4x squared plus 2. Now you can see that there are 2 terms there. So there's 2 terms, and that's the reason this is called a binomial. Can anybody think of something that has a prefix bi? Try to keep it clean. A bicycle. So yeah, the traditional remembering that a binomial has 2 terms is a bicycle. So I'm going to draw a picture of a bicycle. A trinomial is obviously, is obviously an expression with 3 terms. And each one of them has to have a different little number on top. Each one of the 3 terms has to have a different exponents. So Jarosette, what did I just say? Each one in the expression, each term has to have a different exponent, the little number on top. So like if this was 3x to the 4th, then I can't use that 4 again. Plus 9x squared plus 1. So there are 1, 2, 3 terms in that expression, and that's the reason why that's a trinomial. Can anybody think of a word that begins with the prefix of tri? A tricycle? Yeah, I could draw a tricycle. I'm not very good. A triangle? Yeah, triangle would definitely be a good example. Another example is a triceratops. So let me see if I can draw a triceratops. and then he's got a horn here, and a horn here, and then he's got a horn on his nose. Okay, so everybody, no one in class said that they had seen a picture of a Triceratops before, and so these are Triceratops, and they have two horns on the top of their head, and then they have another horn on their nose. Okay, a term is one part of an expression. And I'll do an example of that in a second. So the coefficient is the number in front, and an exponent is the little number on top. Now that is not a formal definition, but I'm not aiming for that at the moment. Yes? I will, yes.
He has a new CCP.
Okay, thank you. Okay, so for example, this is, that right there I would call the second term. It's one of the parts of an expression. So this is the first term, the second term, and the third term. That right there is the second term. A term is one of the parts of an expression. The coefficient is the number in front. So in 3x squared, x to the third, the coefficient is the 3. So it's the, if I say what's the coefficient of this term, I would say that's the number in front on that term. So what's the coefficient of this term? The coefficient of the first term is 4. Okay, so what about the exponent of the first term? Is 2. So the coefficient is the big number in front, and the exponent is the little number on top. Okay, so in 4x to the second, it's the little number on top, which is right here. Okay, so if I were to use a dot to mean a number, like the number 6, and a line, so this is example 1, the next one's going to be example 2. The new thing that we've learned is that terms are like only if they have the same exponents, which means that I can only add two terms together if they have the same little number on top. So if I use a picture, that would be a dot means a number, a line means a u, and a square for u squared, this is u squared. Then I have 1 square plus 6 dots, that's a dot because there's no u's, and then there's 1 line here and 6 lines here. Using this picture, I can see that I can only combine the plus u, because that's a line, with the other 6u because those are lines. I can't add the square to the dots because they don't have the same picture, or because they don't have the same exponents. Now, I was going to call on Yahira, first Jasmine 1, which other term, first, second, third, or fourth, can I add to the third term I circled? The fourth term. Yahira, which other term can I add to the u? This one over here, the 6u, the fourth term. Okay, so I can combine the u and the 6u, and I'm not going to draw a V shape because that would mess up my drawing. U plus 6u makes 7 u's. Okay, what about these other two terms? I can't combine those two terms at all, so I just have to leave this expression alone. So it's u squared plus 6 plus 7u. Why can I not combine this one and this one? Use the word exponents. Why can I not combine those two? Kareem. Right, they do not have the same exponents, or you could also say they do not have the same degree. Now, just as a matter of convention, when we're writing these problems, it seems neater to put them in from highest exponent to lowest exponent. So I would move this to u squared plus 7u plus 6. So it would be the most u's over here, and then the second most u's, and then no u's at all. So you usually put these from highest degree to lowest degree. So this would be correct, but this is also could be correct. Incidentally, what did I just do with these two terms? If I switch the order, what's the name for that? All right, now for the second one, I am not going to draw the picture, the pictorial representation. I'm just going to add my like terms. When I am adding like terms, I'm not. This is a plus here. I'll teach you tomorrow what to do if it's a minus, because you're going to have to distribute that negative. But for right now, we're just going to circle the terms that we can add together. So in example 2, my very strong advice is to circle your terms. When you are circling your terms, Jose, you need to circle the sign in front and the coefficients and the base and the exponent all together. So which of these has the biggest exponents? I'm going to start with the biggest exponents, and then I'm going to go to the next lowest all the way down until I get to no exponents at all. The third term. Okay, so I've got a negative 4b to the third. Is there another exponent of 3 anywhere? No, so I'm just going to draw a line because that comes straight down. 4, don't forget the negative. Negative 4b to the third. All right, next highest exponent is a square. Who sees a square? A b squared. What's a square? Okay, the first term. And I circled the sign, the coefficient, the base, and the exponent all together. That's one term. And Oksana, where's another b squared? And make sure it's positive. Keep the sign and the coefficient and the base and the exponent all together. And then I'm going to put a V shape underneath those. And I've got negative 4 and positive 5. If you have 4 negatives and 5 positives, 4 negatives, 5 positives, how many more positives are there than negatives? 1. So and 1b to the second power. That's an invisible 1, so I don't want to put it. Khan Academy, I believe, will count it wrong if you put invisible 1s. So just b squared or 1b squared, I guess, is okay. And then the last term, I've got an 8b here, and I've got a negative 8b here. So I'm going to combine those two. What is 8 minus 8? Okay, so you could put plus 0 or plus 0b, and that's fine. But if there's no b's at all, then I would just leave it off. So plus 0b is correct, plus no b's. But in algebra, we don't put plus 0. That would be a waste of time, because if you add 0, it just means you added nothing. So I'm just going to put nothing there. Okay, so in other words, I'm just going to put nothing. I'm going to put the word nothing because it means nothing. So my final answer is negative 4b to the third plus b to the second. When will you use this concept? You will use this concept when you are solving problems that have exponents. And there's all kinds of problems that you're going to see like that. We're going to model situations that have exponents. A common situation that has an exponent is when you throw something in the air. So if I throw something in the air and it goes up and comes back down again, that's not a straight line, right? If I throw something in the air, it doesn't just keep going off in a straight line. It would in space. If you threw something in space, it would just keep going in a straight line. But because of gravity, it goes up and comes back down. That is an example of a model that has an exponent. So that's called quadratic because the exponent is 2. And then other situations that have exponents, we're going to solve like algebra problems. So what if you had 3x squared is equal to 4, and you had to solve that? You're going to use these concepts when you're doing those things. So when you are solving problems that have exponents.